Welcome to the lecture series on soft computing in computer science. This session is going to talk about fuzzy logic toolbox in the MATLAB software. We have seen so many lectures dealing with the concept of fuzzy logic, starts from fuzzy set theory, fuzzy operations, fuzzy inference systems, fuzzy expert systems, and a lot other case studies with dealt with the fuzzy expert system. Here we are going to dealt with how a fuzzy based expert system can be designed using MATLAB. What is the MATLAB support for that? So, in the MATLAB environment we have lot of toolboxes, and each toolbox is intended for its own thought process, and this fuzzy logic toolbox helps you to develop a fuzzy based expert system. So, what are the components in the fuzzy logic toolbox? So, as I already discussed the MATLAB environment, the MATLAB environment comes with console mode, command mode, and a specific set of graphics mode where you can interact with the software to design the system specific for a particular purpose using a computational intelligent techniques model and other related scientific computing models. So, this session we are going to dealt with how a graphical user interface are present or available in the fuzzy logic toolbox that supports you to develop a fuzzy based expert system. Particularly the case study that we have taken to illustrate the development of fuzzy based expert system is dinner for two, that is the tipping problem. So, the fuzzy logic toolbox, particularly MATLAB fuzzy logic toolbox, facilitates the development of fuzzy logic system using two things. One is graphical line user interface GUI, another one is command line functionality. This tool can be used for developing two different venture. One is fuzzy expert system, another one is adaptive neuro fuzzy inference system, that means combination of neural network and fuzzy inference system. Accordingly, one is FIS model, another one is ANFIS model. So, using the same fuzzy logic toolbox, either you can develop the fuzzy expert system model, or you can do a combination of neural network based fuzzy expert system model, that is ANFIS model. So, coming to the graphical user interface, when you enter into fuzzy toolbox environment, you can find 5 different GUI tool, that means 5 different windows, one for building, one for editing, one for observing the fuzzy inference system in the fuzzy logic toolbox, and some other toolboxes are there, some other GUI windows are there, that is my rule viewer and rule editor. So, FIS editor, membership function editor, rule editor, rule viewer, surface viewer. So, these are all the 5 different GUI window that is necessary for building, editing as well as visualizing the fuzzy inference system environment. Let us see one by one. So, you look at the picture, see there is the window, this is the first window that we are going to interact with, and this window is FIS editor, fuzzy inference system editor. So, and the second one is membership function editor. So, here you can design the membership function and all, and the third is a rule editor, third is rule editor, here you can enter the rules, that is so as we said in this previous session, this 2 and 3 are going to be knowledge base, and this FIS editor is going to sit as a heart, as a control unit that executes the thing with respect to the input data as well as the output that what we have expected. And this rule viewer is the one where you can see the execution of the rules as well as the output that we are going to receive from the rules. And the surface viewer, we can see the rules that has been fired and how much of data it has been accommodated during the firing process, and everything we can see in this surface viewer. So, these two are visualization tool, or we can get the output according to the kind of input, and these two are creation of knowledge base, and this one is the control part, that is the execution part. Fuzzy inference system editor. If you could see that you have the provision for two inputs, these two yellow colored one are meant for input. As for this tipping problem, there are two input, one is service, another one is food. So this two input has been given. How can I add more input? If we have more number of input in the system, for which you can go to edit button. In the edit button you can see add input. Once you add input, this window is visible, you have to interact with, you have to give the name for the input, and you have to set the range for the input 0 to 10. So here I said that the range for the input is 0 to 10, and if you want, what are the methods that you want to do that, say this AND method use the minimum function, OR method use the maximum function, implication is always min, aggregation is going to maximum, and the defactorization is centroid. See, all these things we can give here. So this is the first thing. So under the Fuzz editor window, you can design input, and you can design output, and you can design the model, Fuzz model. We have already seen three models, one is Mamdani model, TSK model, Kong model. So we have seen three models. So here what he has chosen, Mamdani model is chosen. So in Fuzz editor you can decide input, you can decide output, and you can decide the Fuzz engine, and addition to that you can decide these things also. So this is what the Fuzz inference system editor is doing, is all about when you are doing the graphical user interface, right. Next, membership function editor. So in membership function editor, see, we could see that, see these three windows, this meant for input and output, and this is meant for editing the membership function. So if you could see that for the membership function, the variable is service, Now this service is divided into three linguistics, one is poor, another one is good, another one is excellent. These are the three linguistics. For each linguistics you have to assign a membership function. So this is half trapezoidal like this it is going, and this is excellent, and this is going like this, excellent half trapezoidal, and for the good we have this is going to be bell shaped membership function. See, what are the kind of membership function? That triangular membership function, trapezoidal membership function, generalized bell membership function, Gaussian membership function, right. So all these things are there, So here you have to give the input, and here you have to mention the range. What are the two input variables? Service, and it is a input variable, and another variable like that. So while you are going to enter the kind of membership function for the kind of input variable as well as output variable, you should enter the value accordingly in the space provided, right. So if you look at this window, that is the membership function editor window, first you need to create the two inputs according to the system and one output. These two, next after creating the input, then you have to divide the linguistics for service as well as food, rancid, delicious, service, accordingly the membership function variables are there. So for the output also you have to divide the same thing, the tip, generous, cheap, like that. So accordingly you have to decide the membership functions. So what we have discussed is the same thing. So what are the membership function you want? You can also choose it from here. So these are all the things that you need to take care while editing the membership function. Next, rule editor. How to edit the rules? So how the rule? How a rule is there? If condition, then consequent. If condition, then consequent. This is the general format of the rule. So likewise, if you go to the rule, see there are three rules as far this tipping problem is concerned. If, let me read the first rule, if service is poor or food is rancid, then tip is cheap. So this is the first rule. How can I edit this rule? How can I write this rule in this window, particularly in the rule editor window? Now see, look at this, If service is poor and food is rancid, then tip is cheap. So, one rule is override. Likewise, if service is good and food is delicious, then the tip is generous. So, like that you have to divide. So, if you want to add negation, negation not is there. If you want to do any connections by means of or and, so these are there. So, after doing all these things you have to give the add rule. Suppose we want to change any rule, select the rule, click the button change rule and change that rule option. If you want to delete the rule, select the rule and delete the rule. So, in the rule editor window you can find, see, this is the space allotted for displaying the rules, but how to create the rule. So, buttons are available here. So, the if condition part is here, this is if part and this is then part. So, in the if part you can have more number of variables and all variables can be connected by means of and. If you want you can use or also. And inside each and every variable you can find the linguistics. So, based on the kind of the linguistic variable and with the another variable linguistic, what condition that we need to decide whether the tip is cheap or average or generous. So, we are going to decide that things. So, accordingly we need to change the rule, add the rule, delete the rule. So, these things that you need to taken care of. So, this is what the rule editor is all about. So, this is the graphical user interface. So, next one, rule viewer. See the how the rules are fired. See, this one is nothing but rule 1, this 2 is nothing but rule 2, this 3 is nothing but rule 3. Now, the 3 rules, as we have discussed in the theory sessions, like how the fuzzy inference system is executed, these 3 rules are simultaneously fired, and the simultaneously fired rule has been cut in 3 variables, service variable and a food variable. How can I give this input 3 and 8? See here I have given the variable as 3 8. That means for service my rating is 3 and for food the rating is 8. So, if these 2 input variables given, this slide window, this slide bar, right, this will go this side according to the input. So, accordingly for service equal to 3 the value is cut here, the value is cut here and the value is cut here. So, based on the fuzzy operation, implication method and aggregation method, so the values has been taken, this is cut here and this is cut here and this is cut here. So, we have taken all these things, max mean and max product, whatever the thing that has been designed, and from this value we have taken the centroid of area or whatever it is, whatever the fuzzy defuzzification strategies we have applied, that thing. So, if the service is 3 and the food is rancid, then tip is, it is calculated as see 14.8. So, this is what the expert system is doing based on the firing of the rules that we entered in the rules. So, the rule viewer is the one which helps to display the rules, view the rule firing process as well as to receive the input, for which you have to give the input 3 8. So, now for the input 3 8 we have got the value service equal to 3 and food equal to 8. We have noticed the cut point because all the rules are simultaneously fired. When all the rules are simultaneously fired and the cut points of the each and every rule in the membership function of the particular input variable has been noted down, and when 2 or more variables are there, for based on that variable what we have taken max min. If it is max min computation, first we have to take the max, then we have to take the min. Then according to the implication method we can either go for min or max, and finally we have to aggregate. So, we need to go for the maximum. So, min max. So, first maximum operation, then the minimum operation, then the max min composition, then followed by the centroid, that means a defuzzification process. So, finally you got the value and the value is displayed here. So, now this window is treated as the expert system. Now, the owner of the restaurant can see person to person what is it. See, say for example person 1, we have a 2 rating, service, food. Now, a customer is entering the hotel, taking the food, and after leaving the hotel he may give services. For service he can give the rating 4, and for this we can give it. So, what are I give to give? I have to give 4 9. If I give 4 9 here, then I have to get the percentage here. So, for the service 3 equal to 4 and for food equal to 8, my percentage is 14.8. That is, if the person have taken food for 100 rupees, he can receive the tips of 15 rupees approximately. Likewise we can, so likewise I can get for every customer, customer 2, customer 3, customer 4, what is the service schedule, 99 or 10 9 or sometimes 1 2, like that value. For each and every rule you can record it here, and so now this entire the rule viewer is viewed as an interaction viewer of the rule firing process by accepting the input from the user and display the value or display the output. In addition to that, it display the rule firing process in the two-dimensional view. So this is what the purpose of this rule viewer. Next comes the surface viewer. So in surface viewer, let me take this is the core whole part. This shows output of any surface for any system which is 1. That means, see here, service food is taken. It shows the output surface for any system output. See, it is going to produce output, right? What is the output? Tips with any other input. So it is the window showing the surface covered by the rule viewer for the set of inputs with respect to the output. See here, the service food is taken and the food is taken and the input service is taken. What is the output? Tip. So this is the thing. So the X grid corresponds to food and the Y grid corresponds to the service. X grid and this is Y grid. So now we can view the output in under which category the rule. See, if these category the rule can be fired like this, and if the food is 5 to 10 where this rule can be fired. Suppose if this is a combination, that is the combination. See, like that we can see where the points has been. So this is can be viewed as a point in a 3-dimensional space. So here only our problem can be converted into a search and optimization problem, and based on the search and optimization problem we can define any other algorithms like genetic algorithms or particle swarm optimization to propose the idea. So this is what the surface viewer is all about doing. So the dinner for 2 problem. So what is the rules for tipping? If service is poor or the food is rancid, then tip is cheap, maybe 5%. If service is good, then tip is average. So it is no need of thinking about the food quality. This rule is based on only the service. Service is good, then tip is average. What is the third rule? If service is excellent or the food is delicious, tip is generated, that is 25%. See, this is what we have explained. All the rules have been simultaneously fired. So service equal to 3, food equal to 8. So where it has been given, if service is excellent, this rule is third rule, and this rule is the second rule, and this rule is the first rule. So accordingly the rule firing has been happened. This is already been explained in the previous sessions. And however, so this window is equivalent to this one, same thing. So 1 2 3, this window is nothing but this is the MATLAB rule viewer window, and this MATLAB rule viewer window is showing how the rules have been fired and how the cut point values have been taken, how the max min composition, implication methods and aggregation operations have been performed, followed by the defalsification in order to derive the output. So everything can be visualized, and I had told that we can drag this window or we can give this input here like any other, like a table of values you can give, and you can check what is the tip amounts, and you can make an expert like that. So you can do that. So the same thing is explained using this conceptual diagram, this one, right. So this is the membership function chosen for the variable service in each and every rule. In rule 1, if since the service is poor, the half trapezoidal, and in service is good, in second rule it is generalized Bell MF, and it is a half trapezoidal if the service is excellent when respect to the third rule. So this is the rule that is taken with respect to the first variable. And the second variable, it is a rancid and delicious, it has been taken like that. So the tips, what about tips? What about the tips that I can take up? So tip is cheap, tip is average, tip is generous. So these 3 things that you need to taken care of with respect to the output. So after applying the cut point value, that is min method, we have taken this one, and overall we have to apply the max operations, that is aggregation operation. This has been come down, and here we have to take the defacifying method and the centroid method, and this centroid method will give you the output. The output is 45. So this is what the rule viewer or the entire fuzzy logic toolbox is supporting, how the fuzzy concepts has been fired or has been explained for this idea. Here, as I said earlier, this fuzzy inference editor, you can see the values service, right. So now if you click this service, it will open a new window. There you can adjust the values of service as well as the values of the food. Likewise, you can adjust the value of the output variable also, right. So you can add the membership functions. If you click edit, and if you want to add membership function, you can click the add membership function, and you can give the membership function Gauss, MF and 3. So when I click this one, this service, or when I click this food, when I click this tip, whatever the things, if I double click on that service or if I double click on the food, I can open a new window. In that new window I can see how to add the membership function and what is the type of the membership function and how many number of membership functions are needed to represent the entire variables. After that, if you click OK, then the system has been designed, this services system has been designed. Likewise for food and other things that you need to do, right. See, if I click the service, now the service parameter has been come down. If I click the service food, and we can get it the variable like this. And if you want to change the range, you can change, and if you want to change any membership function, you can change. So this is what the membership function editor is doing. So if you want any type of membership function, you can change. You can check the system performance also, whatever the thing that we have chosen, whether it, so. But you could remember that there should be some overlap. There should be some, then only you can say that the fuzzy. Say for example, poor is coming like this, excellent is going like this, and this one is, so there are some overlap. This is some overlap, this is some overlap, this is some overlap like that. So like that you can give the membership function with any overlap between them. Say for example, if you have a data, and you don't know whether the data is uncertain or not, because when you look at the data, it will give only the numbers, it will give only the numerical values. Initially you don't know the uncertainty, vagueness and other things, because when I start explaining the fuzzy logic, I could say that how far the particular destination place is from here. Someone may say that it is not very far away, it is very shorter. So we cannot say exact value for that. So it is not quantifiable, it is subjective in nature. So you, by the words, it is not very far away, it is very short. By the words you can understand that the answer is subjective in nature, and you can very well say that this has some idea of fuzzy logic. But what about numbers? Because when you want to work with the data, you have only numbers. If you have uncertain numbers and if you have a certain numbers, whatever it is, you don't know when you look at the numbers first. So when you want to go for design a fuzzy based system using this membership function editor and all, you always decide a membership function. Say for example, here my 0 to 10 is I have taken for service, but here see this 0 to maybe 4.5, 0 to 4.5 that I have taken for poor, right. And something like here, yes, 1 to 9, so 1 to 9 may be taken as good, right. And some like 6 to 10, 6 to 10 we may taken as excellent. So now we can find lot of overlaps. So when you design the linguistics, before designing the linguistics, for each and variable in the data set, you should decide up to which boundary we can have for poor and what is the range for the another linguistic variable that you have to decide. While fixing the range for each linguistic variable, you should be very cautious that there should have some overlaps between one variable, one linguistic variable to another variable. Accordingly, you can design the system. Rule editor, that we have given enough discussions about the rule editor. Rule viewer, so this is also fine with the rule viewer. So one point that has been thing is, what is this 1? When you look at this, there is a 1, there is a 1, and this is nothing but weight. Suppose if you, when the system is executed, all the 3 rules have been simultaneously fired. Suppose if you want any one rule should have the more weightage, that it should be fired more than some amount of time, when the system is executed. That means you have to give more weightage to the rule. So the weightage to that particular rule can be given here. Wait. See, here all the rules are given the weightage as 1. That means all the rules are equally fired. Suppose if you want one rule that can fire more than the other rule, and it should be very important rule as far as the system is concerned, then you can give weightage to 2 or 3 or some other higher values, whatever you want to fix it. So this is the another idea, that you can increase the weight of the rule, so that the certain rules can be given priority while executing the system. Under rule viewer also you can do with respect to left move button, right move button, up button, down button. So you can view that. It means that this thing will move here and there, left right, here and there it will run. So you need not give the value here 38. If you move the window accordingly, this value has also been changed. Maybe it may be changed to 3.5, this may be changed to 6.5, this may be changed to 7, this may be 7 to 8. So like that the rule can be changed simply by moving this red thing. So this is the thing, and you should always check whether the system is ready or not. Sometimes when you are executing the system, it may turn to a device called busy. Accordingly, it means that the inference mechanism is going on, the rule firing process is going on. Once that process is over, so for simply if you are having 3 rules, the entire system won't take much time and it will give the result. Suppose if your inputs are, if your number of rules are very minimal, then the time is not a factor. You can get the output as such possible. So no need to worry about the status, what is it is showing, whether it is showing ready or whether it is showing busy. You can always go ahead. Surface viewer. So surface viewer also give the same thing. So what is the reference? So what is this reference input? You can give any other input here. Here also you can. If you give input, accordingly the value is changed, right. So this is the range that has been X grid, how many number of grid points have been chosen, and Y grid, how many number of grid points have been chosen. That is the thing here. So the reference should be here also. You can give 3, 8 like that, and you can also check the status of the bar accordingly, how the surface viewer has been carried out for this. But this surface viewer has a very good options in the option button. You can also rotate the surface viewer like this we can view whichever the data point is giving a lot of results and all. See, this is the tip amount, see X, Y and Z. So you can view the options also. After changing the options, you can use this view to view the idea where the system has been turned up and what rule has been fired effectively and which rule has a place, a vital role in understanding the entire system, like that at all you can see using the surface viewer. So with this we ended with the fuzzy logic toolbox environment. In this presentation I have given some idea about what are all the windows that has been available in the MATLAB software that supports the development of fuzzy expert system or fuzzy inference system. On the other hand, I can say the fundamental requirement for developing this fuzzy expert system using the MATLAB software environment is, as we discussed in the conceptual presentation, you need membership functions as well as the rules. How to derive the membership function and rules? So by means of intuitive, you can choose that, or you can go for some other approaches. But this fuzzy logic toolbox usage assumes that now you are ready with the rule as well as ready with the variable as well as ready with the linguistics. So all these things are ready. Once all these things are ready, then you can design the system. First you use the Fuzz editor, then you use the rule viewer. In the Fuzz editor you can find all the things, add MF, range, then the rule editor. So Fuzz editor, rule editor, then finally rule viewer. These two plays the design part and this plays the execution part. So this is what the MATLAB toolbox is all about. In the subsequent sessions we can see about how this toolbox can be effectively used as a practical session, and we are not going to limit with dinner for two, that is a tipping problem alone. We are going to dealt with how the fuzzy washing machine control can be used, how the turbine controller problem can be used, and how the flower classification problem can be. So all these problems we can design. Once the design has been done. What I can do, sir? How can I save my file? Whether I can save? Yes, you can save this file as a .fuzz, and you can open the file whenever it is required in the fuzzy logic toolbox. So .fuzz, fuzzy inference system. Say for example, if I save this file, what is the file? Tipper. See, my file name is tipper. So tipper.fuzz, it is stored as tipper.fuzz. So likewise, you can proceed with all kinds of stuff, and it is very easier and friendly software to know, to understand the uncertainty present in the data through the concept of linguistics. So with this, this session is over.